Here to do days 3 and probably 4 of the Advent of Code. I see problem 4 is up here. Have not looked at it yet. Have looked at number 3, but I haven't started working on it. So as usual, we'll be doing it in Ruby and drinking mint tea. So let's get down to it. Day 3, crosswires. The gravity assist was successful, and you're well on your way to the Venus refueling station. During the rush back to Earth, the fuel management system wasn't completely installed, so that's next on the priority list. Opening the front panel reveals a jumble of wires. Specifically, 2 wires are connected to a central port and extend outward on a grid. You trace the path each wire takes as it leaves the central port, 1 wire per line of text. Got it. That's my puzzle input down below. The wires twist and turn, but 2 wires occasionally cross paths. To fix the circuit, you need to find the intersection point closest to the central port. Because the wires are on a grid, use the Manhattan distance for this measurement, sure. While the wires do technically cross right at the central port, where they both start, this doesn't count, nor does a wire count as crossing with itself. For example, if the wire's path is R8, U5, L5, D3, then starting from central port, blah, blah, blah. Example, I think I already understand all of this. But before I go any further, I'm going to go open up my chat so I can see if anyone actually says anything, because I forgot to do that. It's my stream chat. All right. Perfect. What is the Manhattan distance from the central port to the closest intersection? Got it. Oh, and there's our input. So let's take that, and we are using iTerm. And I have 2 different terminals open. Perfect. So I'll pop that in there. And we got the extra line. So we have 2 big long lines. That is a lot of numbers. How do we want to do this? I mean, I kind of just want to make a set of coordinates that each wire touches and then find the intersection of the set. Kind of feel like despite these really big numbers, that's probably fast enough that I won't hate that I did it that way. So that's the idea. I'll read through the lists, through each of these lists, generating all the coordinates that a given wire touches. I'll use a set to represent that. Ruby has that out of the box. And then I will find the intersection of the set and look for the one with the smallest Manhattan distance from 0. Cool. And just double check here. Manhattan distance is just, you add the things together, right? Yeah. It's just the number of blocks you got to walk. Cool. Okay. So let's take each one. So these were comma delimited. So we're also going to map them line split. I think that'll probably look kind of like what we need as for starters. And put, of course, and I'm thinking it is a 2-dimensional array. That was good enough to me. Okay. So what do we call these things? Uh, call wire A instructions, B input 0, and wire B instructions. And then we'll go A coordinates set, B coordinates is set, and then we'll do some work here, and then we will, okay. Some work here, and then I think intersection is the ampersand operator. I'm gonna have to double check that one. I'm not confident on that. Set intersection Ruby. Yes, it is. Yeah, comments that, yeah. Yes, it is. Perfect. So we'll just do, we're looking for, what do I have to put in at the end? Manhattan distance from the center port to the closest, closest intersection. So map this coordinates to, oh, we'll map the coordinates to some, and then we'll find the minimum. That should give us the answer, right? Perfect, except we forgot to do the work. Okay, and let's make this not lazy because there's no benefit to that here. Cool. Doesn't do anything because we're not actually doing anything with the inputs. All right. So cool. Good thing. Got to do that. Have any? No viewers. Well, that's fun. Perfect. Well, we're going to make a method that takes in the instructions and spits out the coordinates. So we're going to say up here, we're going to say coords input 0. And there we go. Sure, we just have to do this part right. So we say coords. Well, let's just use reduce. Why not? Everybody loves reduce. This is the syntax, right? And I will never in my life remember which thing comes first, and I'm okay with that. And I got it right. Well, it's a miracle. That's going to error out. Perfect. So we need a current location. Current, or we'll say current, we'll just, that's way too much to type. X equals 0, y equals 0. And then we need to take our instruction and the distance is going to be instruction 2a, or sorry, 2I, and the direction is instruction. Can you just index strings maybe? I feel like direction. Excellent. So these are all left, right, up, right, down. U, L, D, R. Cool. All right. So then we can do, I mean, this isn't actually a reduce. I should stop pretending it is. Chords. This is a just an H. Is this that each with object or something? That sounds like a thing. I don't know that I've ever used that. Maybe each with object. I don't really know why that would be better here, but I should pass in the current element and the memo to the block, handy for building up hashes or reducing collections down to one object. So it's like reduce, except we don't care about the return value, right? Memos never changed, it does not. Yeah, okay. Sure, why not? Something different, each with object. And it uses, memo is the second argument for this one. Does that make enough sense? Alrighty, so we don't need to return anything, that's kind of handy, and then we can do case, direction, when U, when D, when L, when R, else raise something bad happened. Cool. All right, and as of now, we have, oh, welcome welcome to our one viewer. And here we are going to do dist. There's no point in putting 0, 0 into the set because that doesn't count. They told us that. Oh, tea's still pretty hot. Times do and we're going up, so y plus equals 1, and then into our chords goes the current coordinate. And we'll do the same for this, but a minus, and we'll say it'll do the same for this, but it'll be x, and we'll just do the same for this, but it will be a plus. That kind of looks like it should work. I'm sure it won't for some reason. Wrong number R, it's given 0, expected 1, line 17. Instructions. 0, expected 1. That should be shadowing that. Sorry, what? What is this error? 50. Oh, there you go. That's a problem. off screen. Solution, nothing. Well, that's cool. Well, that worked great. Let's take a look at what we got here. Wire A chords should be a set with lots of stuff in it, and it's a set with not anything in it. Well, that's interesting. Start here. And then maybe we'll try here too. Right. Instructions is exactly what I expect it to be. Excellent. And once we get in here, distance is 0. Instruction is, I was thinking it would just throw away the stuff before. See, that works, but I guess this doesn't. Bummer. So if I want to take this and do slice, was it 1, -1, something like that? No. -1. That works, right? Cool. So just do that instead of this nice little hack that I thought I was being clever. Doesn't work at all. So now we got times for a string, and that's because I didn't call 2i on it, because it still needs to be a number, and we still get no solution. So at least we're getting a little further. All right, direction is a thing, distance is a number, this is, everything is what I expect it to be. Now, let's look at chords here. I hit, okay, that is a nice big set of things. If I'm, what am I missing? Okay, let's back out because that looks like it's generating the right stuff in there. And wire A chords is a big set of things. Okay. What about wire B chords? That's a set of things too. And we can't just add them together because we need to take the absolute values of them. So that's fine. Map. I have to do a non-trivial map in here. So confused as to why I'm not getting a value out of this. But let's just see in a sec here. So we'll map the chords to chords.map abs .sum. That'll work. Still no solution. Why are we no solution? So we know this produces values. Ooh. And there's my typo. Right, so I am finding the intersection of the coordinates and the instructions. Come on, chat, you gotta call me on that. And gets me a value which I can plug in and hopefully is right. Whoa, gold star. Drink some tea. All right. Turns out the circuit is very timing sensitive. You actually need to minimize the signal delay. To do this, calculate the number of steps each wire takes to reach each intersection. Choose the intersection where the sum of both wire steps is lowest. If the wire visits a position on the grid multiple times, use the steps value from the first time it visits that position when calculating the total value of the specific intersection. The number of steps a wire takes is the total number of grid squares the wire has entered to get to that location. Okay, we can modify our algorithm to do that. We're considering an example. We're doing a bunch of math. I am going to not read it all out loud. What is the fewest combined steps the wires must take to reach an intersection? Well, I've already basically got the list of intersections, so I can just trace it again, keeping track of the number of steps we've gone. And record that somehow. Yeah, the only trickiness is making sure you don't double record it if you hit there twice. Seems pretty straightforward. I just realized we're in like my orange evening hellscape here. Let's maybe go Christmas colors, eh? Let's get some Christmas vibes going here. Ooh, yeah, that's weird. Cool. Definitely what I was going for. Make sure we, oh, come on, there we go. Make sure I have my chat up so I can see all the people who aren't talking to me. Thank you, one viewer. Alrighty, get back to the terminal. All right, guess we should commit that. 2019 day 3 part 1, cool. All right. So going to Roxy is here, though she's being very, very quiet. She's in circle configuration right now, little donut. And then here, so that will give us the that should not have changed our results. Oops. Perfect. So, and then we're going to do something not unlike this, but different, you know? I want to do it. Maybe like a hash or something. All right. So for this one, we are going to, once we've got the intersections, how do we do this? We need to go over each set of instructions, recording the first time. So we're going to say record things, or sorry, record. I'll use a better word than things. And we'll say wire here. And that way, we can also have the intersections. I want to be a hash where the key is the intersection and the value is another hash. And then we can set the A and B keys on it. So then we can do chord distance, A, input 0. And do the same thing for B. And then, no, that's not a hash yet. And then we'll do hash.keys.map. Sorry, not keys. Hash.values.map. And each is just x.keys.sum. I did it again. X.values.sum. Dot min. So we just gotta make chord distance do the right thing and build this hash. And building the hash is as simple as taking each one, mapping it to itself, and an empty hash, and calling a 2h on that. Pretty sure that works, but we will test it out. And that produced a hash that looks exactly like I want. Fantastic. So those are all the intersections, and then we just need to populate that with the distances at which A and B both get there, and then should be good to go. So to do that, we still need to keep X and Y, but we are no longer now we actually do want. Nah, we still don't want to use reduce or inject. Distance equals 0. We're not recording coordinates, so this just becomes an each. This just goes that. And instead of looking at these every time, or recording these every time, we say if I'm going to do that, so I have access to it down here. And then if each, if hash.keys include xy, then we say then hash xy wire or equals distance, and everywhere we need to do distance plus equals 1. And there, 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 and there, and there. Just beautiful code design. The copy pasting is truly exquisite. I mean, that's basically what I said I wanted to do. Think it works? Slow. Should be Slightly slower. Boom, right answer. Lost my viewer, but as long as we got the right answer, you know? All right. And this is 2019, day 3, part 2. Nice. Push that up. It's good tea. Good mint tea. Okay. All right. Next up, let's do the next one. I'm just going to